In this video, we'll talk about exponent function, that is m power n. So raising m for n times, that is multiplying m for n times. So for this problem, we will try to define a recursive function. For that, first of all, I will explain what the problem is. See, suppose I have to find out 2 power 5. So this means 2 into 2 multiplied by 2, and this is multiplied by itself for 5 times. So it means m power n means m should be multiplied for n times. M should be multiplied for n times. Now this, if I write it as a power function, that is power m comma n, then it means m into m into m, that goes on to n minus 1 times into 1 more time. This will continue for n minus 1 times and 1 more time. For example, 2 power 5, see, this is 4 times. This is 4 times. And 1 more time. So same way, m power n means m should be multiplied for n minus 1 times, then again multiplied by 1 more time. So it becomes total n times. Now this I can define it recursively. I can say power of mn is power of m comma n minus 1 times into m. So yes, this can be defined as a recurrence relation, power of m comma n minus 1 into m when n is greater than 0. When n has become 0, then when n is equals to 0, as it is a product, so it should return 1. So minimum value is 1. So that's it. So for this mathematical definition, I can write a recursive function using C or C++. So let me write a function here. Integer power int m comma int n. If n is equals to 0, return 1. Otherwise, return power of m comma n minus 1. So that's all. It is just a 2-3 line functions. It's a simple function. So this is converted into a recursive function. I will take one example and show you how it works. Let us trace this one for power of 2 raised to 9. So 2 raised to 9, m value is 2 and n value is 9. So 9, that is not equal to 0, so it should perform this operation. That is power of 2 comma n minus 1, that is 9 minus 1, that is 8. So I will rewrite it as 8 multiplied by m. So what is m? This is 2. So that's it. Continue. Now this call has to be finished, then only multiplication will be done. So what this call is? Power of 2 comma, as this is 8, it is not 0. So every time this has to be done. So this will become 7 multiplied by 2. Then again power of 2 comma 6 multiplied by 2. And power of 2 comma 5 multiplied by 2. Power of 2 comma 4 multiplied by 2. I'll finish this. So that's all. I have made all the calls, and the last call is 2 comma 0. So 2 comma 0, when n is 0, it returns 1. So this will be 1 multiplied by 2. So result is 2, and it returns here and multiplied by 2. Again it is 2 square. 2 square returns here. So this is multiplied by 2. So this becomes 2 cube, and so on. So I don't have to work out on this one. So you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 2 is multiplied. So the result is 2 power 9. So for value of n as 9, it has made a total 10 calls. 9 to 0, total 10 calls. So n plus 1 calls. So now you know how much time it is taking and how much memory space it is consuming. As there are 9 plus 1 calls, so it is n plus 1 and it is order of n, time is order of n. And what is the size of the stack? That is also order of n. Because the number of activation records created inside the stack are dependent on the number of calls, that is n plus 1 calls. Now one more thing we should analyze here, we should observe here. Total how many multiplications it is performing. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 multiplications are performed. So is it possible to compute this one with less number of multiplications? Let us check. Is it possible to do that? See, here if suppose it is 2 power 8. So 2 power 8 can be written as 2 power 2 and power 4. So this is 2 into 2 power 4. So it means if I perform one multiplication on the same value, then power will reduce by half. Power will reduce by half. And suppose it is 2 power 9, then this can be written as 2 into 2 square power 4. So because it is odd, we can't directly make it half. So first 1, 2 I have taken it out and this I made it as 2 power 8 again. So I can make it half. So if the power is even, then I can directly half it out. So if the power is even number, then I can directly take half of the power, and if the number is odd, then I can take one multiplication extra and then I can take half of the power. So if I multiply the number directly, then the power is getting reduced by half. So with this observation, we can write a power function faster than this one. So let us rewrite that power function. Here I will write on power function, integer, I'll give the same name, power, though it's a new version, m and n. First of all, if n is equals to 0, then return 1. Now next check if n is even. If n is mod 2, if it is equal to 0. If n mod 2 is equals to 0 means number is even. If power is even, then I can reduce the power by dividing it by 2. So let us write that code here. So if it is even number, then return, call power function and multiply m into m. So one multiplication, that is m, is multiplied by itself for one time, then this will be n by 2. That's good. So number of multiplication will reduce further. Then else means number is not even, power is not even, power is odd. If power is odd, one multiplication is extra. So I will write down return m into power of m into m, comma, n minus 1 divided by 2. If it is odd number, then one multiplication we are taking here directly and then n minus 1 by 2. So n minus 1, it will become even number, then divided by 2. So let us take an example and trace this function and see in how many multiplications we can get the answer. So I'll take the same example, that is power of 2, 9. So we are looking at this function. This is a new version of a function which is having less number of multiplications. So let us try this. Power of 2, 9. This is 2 and this is 9. So n is 0, no, n is not 0. So n is even, no, it is not even. So it is odd, so it will enter here. So m into so and so. I will write on those things directly here. 2 into power of 2 into 2. So I'll write 2 square. See, this is m into m. So 2 square, comma, n minus 1 by 2. So that is 9 minus 1 by 2. 9 minus 1 by 2. That is 8 by 2. So it will be 4. So I will rewrite it as 4. So 2 square, that is 4, comma 4. So this is the call. Now again a call is made. This time this is 4. That is 2 square. So 2 square and this is 4. So 4 is not 0. 4 is a even number. Even number. Just there is a call with multiplying m into m and n by 2. So let us take a next call, that is power of m into m. M is now 2 square. So it becomes 2 square into 2 square. And this should be by 2. So 4 by 2. 4 by 2. That's what we have to do. So you can see this line. So this I will rewrite. So 2 square into 2 square. This becomes 2 power 4. And 4 by 2. So this becomes 2. This is a new call again. Then let us continue. 2 power 4 and this is 2. 2 is not 0 and 2 is even. So it will enter into this part. So next call, that is m into m. Power of 2 power 4 into 2 power 4, comma n by 2. So this is 2 divided by 2. So I will rewrite this one. So this becomes 2 power 8 and this becomes 2 by 2 is 1. Now this call, this is 2 power 8 and this is 1. This time n is not 0 but even n is, this time n is not 0 and n is not an even number, it is 1. So it enters into odd part. So in that, m into power of so and so. So m is how much? 2 power 8 into power of m into m, that is 2 power 8 into 2 power 8, that is 2 power 16, comma n minus 1 by 2. 1 minus 1 by 2, that is 0. So this is the last call. Now n has become 0. So for 0, it returns 1. So this for 0 value, the return result is 1. This is 1. Now what it will become? 2 power 8 into 1. 2 power 8 into 1. So this is 2 power 8. And 2 power 8 goes here. So this becomes 2 power 8. And 2 power 8 goes here. This becomes 2 power 8. There is nothing. No multiplication is there. Just return. And 2 power 8 goes here. So this is 2 into 2 power 8. 2 into 2 power 8. So this is 2 power 9. And 2 power 9 goes here. So wherever the call was for odd number, there is one multiplication. Even number, there is no multiplication. Simply it returns the value. So finally we got the answer, that is 2 power 9. And total how many multiplications we perform? One multiplication, and here we have taken square of this. This was 2 into 2 actually. So 1, 2, then 3, 4 and 5. Here also one multiplication, 6. So just in 6 multiplication we got 2 power 9. In the previous version, for this one, it has taken total 9 multiplications for getting the answer when the power was 9. But now for power 9, this has worked faster and we got the result in just 6 multiplications. So that's all about this power function. So we have a faster version of exponent, that is power function also. The same function can also be written using iteration, that is using loop. So that's again a student exercise. So you have to do it. So we will continue looking at more example of recursions in coming videos.